Hi, I'm Steve Jones and I'm going to explain the domain theory of magnetism. Now this is a very important thing because ferromagnetics are very different in character from other materials, even though all materials exhibit some form of magnetism. Within a ferromagnetic, within, for example, iron, steel, so on, it is seen that there in fact are what they call domains. These are large areas in which the magnetism of the individual atoms and molecules are all aligned in the same direction. So overall, the material is not magnetic because there are as many pointing in one direction as the opposite direction. So on average, there is no overall magnetic field. But as soon as a magnetic field is applied to the ferromagnetic, what happens is, at first, when it's a small field, well, the domains in that direction start pulling atoms from the other domains into that direction, and then, eventually, when the field is large enough, these domains start snapping into the one direction of the field. So, for example, this one will, at some point or other, suddenly orientate it totally the opposite way, in line with the magnetic field that is being applied to it. And this effect, when you take away the field, this does not necessarily disappear. In some materials, like steel, it actually remains like that. In other materials, like soft iron, it gradually reverts or it suddenly reverts. It depends on the material itself. But the huge advantage of this is that magnetism is affected by whole bunches of atoms, which we call domains, and the whole domain actually switches into that direction. So the effect is very large compared to other materials where just atom by atom they'll snap into a certain direction. And because of the temperature causing the atoms to move about, they tend to demagnetize as quickly as they magnetize. In other words, they don't magnetize at all. So that, in a very simple form, is the theory of domains and how a ferromagnetic material becomes magnetic.